Okay, let me share my screen. Okay, I think we're live stream now. Hello everyone, this is Shooting Zhao. Welcome to the Kyverno contributors meeting. Today is May 6, 2021. And we only have one topic in today's agenda, which is that I'll give the updates of the high availability support. And if anyone else has any other topic, feel free to add it to the agenda. Okay, so for the HA updates, I know we've discussed this in the last contributors meeting. And after that, I did some research on the HA libraries. We found that there are two approaches that we can use in Kyverno. One is to use controller runtime, or you could say computer to build up your controllers in the HA mode, or there is another approach I list in this document is that we leverage this client Go library, leader election. So this package provides us a way to implement the callback function so that we can have the leader does the job at a time. So after I discussed with Jim, we feel like this client Go library requires minimum change in the code base. So now the plan is to implement the HA with using this leader election library. So we don't want to use the controller runtime at this point. Okay, to give you some more details, information, or to break it down to different components, modules. So in Kyverno, we have three major components that needs to support HA in order to bring it to the production. The first one is the webhook part, and the second is the generate controller, and then we have the policy controller, which is to audit the policy report. And in the first phase of the HA support, as I listed in this, we have the webhook server and another module that take care of the webhook registration, monitor the webhook, and renew the certificate. So for the first module, webhook server, this is where Kyverno receives the admission request, applies the policy to those data, and then return the decision along with the admission response. So in this module, we don't need the leader election. Whenever we scale Kyverno up to multiple instances, the Kubernetes service or the Kyverno service will load balance those admission request traffic and then forward it to the different instance of Kyverno. So we don't have a problem here, but the thing is with the generate policy and the validate audit policy. So here we don't process those two types of policy in real time. We kind of have this post action is that we first see this admission request and we have a generate policy or the validate audit policy that can be applied to this request. We return the response immediately, and then we push this kind of request data to the queue or channel, and then we process those. So this won't take any time in making decision in the admission review process. Instead, we kind of post-process those. The problem here is that if we have multiple instances running for this webhook server, we will have to, let's say when it's in terminating state, we'll have to drain this queue or the channel to have some sort of gracefully shutdown process so that we don't lose any of the items in the channel or the queue for the generate and validate audit policies. But thinking of those kind of policies, we have the intermediate resource created. For example, for the generate policy, we have GR. So I guess that's the place we need to guarantee if this instance is shutting down, we need to make sure that GR is created so that the other instance can pick up that GR. Otherwise, we'll lose that the trigger resource activity. Excuse me. And then the generate policy would fail, right? And
just a quick question to this. So
yep.
Currently we're returning immediately and we are pushing it to the queue. How big would the change be, like just for simplicity's sake, if we immediately when we receive the request, create the trigger resource? And even if we handle it later, because then we would have like a state that would be like independent of the instance, right? Because it would be picked up later by any instance potentially, as far as I understood it.
Right. Yeah, I think the additional timing or the time or overhead we'll add then to the request response flow is just the creation of that resource. So typically, what we've tried to do is limit any API calls in the policy handling. But it could be, so yeah, we could try and create the GR. We'd have to write to the API server, and potentially that could fail, right? So handle all of those type of things.
It's just like for consideration, because I'm not sure if we depend on the queue and we shut down an instance unexpectedly, like what is the behavior right now in Kyverno with a single instance? So I don't see us losing anything. We're just not utilizing HA to the fullest potential.
Right. So I think there's some provision where we do try and drain all the queues before before the process shuts down. Now, of course, I think it's if somebody just does a kill, we won't be able to do anything. But if it's a graceful terminate, we will be able to drain all of the requests. So potentially there's a window where a request could be lost, right? Where like we might not create the GR for it. So that's what this introduces. And I don't think, Shooting, is there any way we recover from that? Do we scan periodically and see? I don't think we have any logic in place to recover if there is a loss, right?
No, I don't think we have such mechanism for generate policy. But
right.
The other point I want to bring is that for the validate audit policy, because if the instance restarts or any other instance becomes a leader, the background controller will pick up that resource and audit the result. So maybe for the validate audit policy, that's fine, but we don't have a way to recover for the generate.
Yeah, I mean, it'd be interesting to think about if we can even kind of make the generate request a little bit more self-healing, right? And later, if we see that there's a resource which matches, which was created after the policy was created, we just go ahead and create a GR for it. Right. Today, we only do the GR in the through the webhook or the webhook server. But there's no reason why we can't do it in the background by doing a check like what I was describing, right? Just checking the time of the policy and the resource.
Yes, but in that case, we have to scan each and every resource in the cluster.
That matches the policy.
Yes.
That matches each generate policy. Right. Yeah, so something to think about, but yeah, and good points. I mean, we could try and do this during the admission control itself, but then the concern would be the overhead of the API server requests. But there is another interesting use case here, and we've heard this from one of the other members in the community is the problem right now is if you're creating a lot of namespaces and you want to rely on certain objects being how do you know when a namespace is ready is the basic problem, right? And if you're relying on certain objects to be created by Kyverno, it is asynchronous. There is a little bit of timing, and if all of this, if you think about if it's driven through like some automation script, that script will say, okay, my namespace is created, but it doesn't necessarily know when all the other resources are created, right, by Kyverno. So in some flows, it almost seems like it'd be nice to have all of this be synchronous and even have like a ready state on a namespace, but I don't see an easy way to control that.
Yeah, so this was also why I was thinking kind of this way, because at least from Tecton, I know that in Tecton, there's like this whole triggers thing where webhooks are processed, and they follow the mantra of the webhook returns as soon as all the resources are basically created and the task is done. But obviously, as you mentioned, that introduced a lot of problems as well. So there you run into problems of if you have a timeout set pretty low on your API server, then it might just abandon the request before everything is created and you're done.
Right. And the actual resource is not yet created. Like the namespace itself is created after we return from admission controls, right? So yeah, it's hard to coordinate. So it's almost like we need like a post create type of webhook instead of the ones we have today, and that doesn't exist, of course, today in Kubernetes, where we're saying, okay, the namespace is created, but it's not ready to provide service yet because there's some post-create operations that need to be completed first.
Yeah, and I see this as being, I mean, the functionality is one thing, but as far as being exposed, I don't know that this is something that needs to be exposed by default everywhere. This might be something that we leave by default as async. And then if somebody wanted that in a specific cluster, they could enable that in, let's say, a Kyverno config map to say that, all right, generate requests for this cluster, maybe even scope it down even further. From this cluster role or something, these requests you should return sync. And then that would sort of be a non-blocking thing for all other users. So I don't know it's a switch that we'd have to throw across, globally across the entire board. But that still doesn't help with implementing the functionality itself, just that this may not necessarily be as huge of a problem, because I think most users are probably fine with it being async.
Right. Yeah. And the main thing I think we should think about is what's the possibility of losing some generate requests and how do we recover from it? If we cover that, I think it should be good. We can certainly consider, trying to do things or create the generate request in line and see what the trade-offs there are.
Right, just to add to a previous point that we have the stop trend. If a user kills the Kyverno pod or Kyverno receives a specific signal, we can shut down it gracefully. This is like for the cases whenever Kyverno panics, then we don't have a way to do that. But if you kill the pod, we clean up the webhook configurations, we clean up the secrets. We do that.
Even with like a -9 kill, it will handle that gracefully.
Sorry, your voice is broken.
Sorry, I was saying even with the kill -9, it will receive the signal and handle that terminate. Okay. All right. Yeah. So you should just make sure, and I think there's ways to also install panic, like a handler for a panic and trigger termination. So maybe we need to look at that and just make sure we're handling. Ideally, if we also do some background checks like with other policies, if we can recover from occasional loss, that maybe okay.
Right. We can have a cleanup go routine, and whenever it panics, we should at least try to recover or do the cleanup job.
Okay.
All right. So this is for the webhook server, and the next is the webhook register, monitor, and the certificate renewer. The reason I put them together is that currently we're managing all those three components inside the same package. So maybe I'm thinking we can change it at the same time. And these three components needs the leader to do its own job. The webhook register is the one who registered the webhook configurations. Currently, each instance during the start, each instance will register that separately, but obviously we don't want to do that. If we're running HA, we want to make sure there is only one instance does the job. And the webhook monitor the same. We are monitoring the webhook configurations all the time. And also we're monitoring if the webhook is active during when Kyverno is running. And then the certificate is that the components renew the certificate. We now store the certificate in the secret. This is for the self-signed certificate. The Kyverno created managed self-signed certificate. But if it's a user's custom certificate, we do not manage that. We depend on the user to renew that.
Okay, so are you thinking we'll just do one leader election for all three of these components, or run three separate elections?
Yeah, that I think we have to dive deep to the code. The monitor and certificate renewer, I believe they're sitting in the same controller. For the register, because we're like registered in different places when Kyverno starts, when the webhook is deleted. So I'll have to check if this is a different controller or we can do it together.
Okay.
But the idea is that only have one leader running at a time.
Yeah, I would agree with that. If we could only have one leader, it would simplify a lot also from a debugging perspective,
Right.
because then it's just a single instance that's the leader.
And the certificate renewer, that only needs to run when it first invokes. That doesn't need to run continually, right?
We want to check it periodically if the certificate is valid.
Well, I guess you would. I mean, it wouldn't need to be, okay. Yeah, I mean, it wouldn't need to be super often.
Yeah, it currently runs every 12 hours. And by default, we set the expiration date for a 1 year. So that shouldn't be much problem there.
I have like just some understanding questions from my point of view. Which ones of these are like really where we really rely on only having one instance, and which ones are like idempotent to the point that in theory it shouldn't matter to be? Because if I read certificate renewer, of course it is beneficial to only have one instance because we could have race conditions.
Yes.
But does each one of these imply a race condition? Like,
no, I don't think we need. I think the minimum requirement is to enable the later election for the webhook register. So that controller is registered the webhook.
But all of them are doing some reads and then writes, right? All of them will be updating things back to the API server in some conditions.
Yeah, but what I'm saying is, if you do the read in multiple places, and each controller individually would have the same write operation, then it basically wouldn't matter.
Yes. Yeah. So worst case, you might end up duplicating some work, you know, but yeah, or the second one will get one of these errors, you know, that says like the object was updated already or something like that, right?
Yeah, and that is then quite easy to recover from. I'm just asking because sometimes it can be easier to just like do extra work instead of relying on the leader election.
Right. Yeah, and I think we shooting had looked at some other controllers and saw that that approach was taken, right? It's more like, okay, just everybody will try the same thing and we expect one of them will fail, right? So.
Right, even in this library, they said the implementation is not guaranteed that there is only one client running at a time.
Yeah.
But the kube scheduler, kube controller are using this library. So I guess we just have to design in a way that if the same process gets executed twice, we want to make sure the results are consistent.
Yeah, exactly. Because if we go into it not expecting a single instance to always handle it, it will be implemented in a way that is a lot safer. That's at least what I realized when I work on operators a lot. Just not expecting that it's the only instance.
Right. So if we get one of those API errors which says the object was updated by somebody
Exactly.
else, we just handle it and retry, and it should
Exactly.
recover.
We should then retry and recheck, and if then there's nothing
Right.
left to do, we're okay.
Yeah.
Okay, it's a good point. Yeah.
Okay, any other questions for the webhook part?
For the certificate, the customer provided certificate, we're going to continue to monitor a secret. And when we detect that secret's updated with a new client certificate, Kyverno is going to go through its restart process internally and apply that certificate, right? So we're going to put a
Yes.
watch out for that cert.
Yes, exactly.
Okay. Yeah. So one of the things that we need to ensure that we handle internally, and this is not probably a discussion for here, is bogus or invalid certificates, either because it's syntactically invalid or the certificate's expired, or we need to have an internal mechanism to validate that that certificate's good and that Kyverno can use it. And if not, for whatever reason, then we revert back to using the previous one in print. Hey, this certificate's invalid, we can't use it, rather than just crashing and dying. That's a little bit more difficult when you're talking about updating an existing secret, because the secret's already been, the API server's already accepted it and we just pick it up. But this is something that that we could think about handling, and being able to, if we owned that secret and we have the ability to cache that secret locally, and if a new secret's populated and that secret, that TLS pair is invalid for whatever reason, we'd have a whole bunch of sanity checks. We just repave it with the existing one. So the use case here is that, the user story is, I update, I'm giving Kyverno a new certificate, I screw up the process somehow, or something happens, maybe it's not in the signing algorithm that Kyverno can use. I'm not aware of it because Kubernetes API says, great, we accepted your secret. Kyverno dies, or maybe it just goes into a loop, but the pod's still running, and then requests start going through if the response behavior is to not be blocking. So it's a protection mechanism to ensure that faulty TLS certificates that were handed don't take out the system.
Right. So is there something, and I think I recall there was a prior conversation on expanding the health checks to cover like whether even the webhook and other things are properly configured. So if a webhook is configured with a bad certificate, the assumption is the API server won't be able to talk to it for whatever reason. So I guess, we'd have to think through, if the first instance comes up and tries to use that new certificate, is there some way to just rely on some of the health checks to handle that, or do we need to do anything? And is it even possible for Kyverno to really test the certificate, right? Because there seems like there could be issues on the client side, which it may not accept that certificate for different reasons, which we still may be exposed to situations where everything comes up from the server side, but somehow the webhook is not properly functioning with the new cert.
Yeah, and that may be something to just table and talk about separately, because it's not super duper relevant here, but just to drop that out. Like, the reason I mentioned is because, in order to get to get acceptable in customer environments as far as production grade, proper certificate consumption is table stakes. Like, you have to have it. It has to be there, and it has to be robust, and has to be secure, and any mechanisms that we can put in that just avoid killing us are going to be really helpful.
Right.
But anyhow.
Yeah, one other related thing to just throw in there is maybe it would be good to look at Cert Manager and to see if we can also integrate with that as an option, right? For just simplifying, managing custom certs, things like that.
Yeah, I was going to mention that as well, but this again is probably a discussion, a separate discussion.
Yeah, maybe Chip, if you want, or I can make a note and file this. Let's log an issue and let's start tracking, because it seems like, yeah, for enterprise consumption, just enhancing the certificate management for custom certs would be good to have.
Yeah, I'll put a placeholder issue out there. I don't exactly know what to put in it, but I can get it started.
Okay, thank you.
Okay, just wanted to mention that currently for the Kyverno managed certificate, we don't have any problem. We have those sanity check, and if it's invalid by any reason, we will renew that cert and manage it on our own. But if it's a custom certificate, yes, we will have to find a way to manage that properly. All right, and the next two controllers, I don't think those are required at this point, because the generate controller, like I mentioned before, once the generate request is created, it's okay if multiple instances pick up the same generate request, because it'll check the status of the source resource, and then it'll check if the target resource is created. So I guess for now it's fine if we don't have it in the first phase, but ideally we also have to elect the leader and then have only one instance taking care of this job.
So at the least, we would need to handle the API error we were discussing previously, right? Whatever the status code is, to make sure that if the object is already updated, we just requeue and retry and refresh and retry, right?
Yeah, we have the requeue mechanism, a retry mechanism in the generate controller currently.
Right. So I think the check though would be, we don't want to flood sort of the logs with errors on that particular error, right? So I don't know how we're handling it today. So we would have to make sure that we always, if the object, if the API server returns that the object was stale, we somehow refresh that one instance and just retry the request.
Right. I think currently the retry logs are hidden at higher log level.
Okay.
If like after 10 or 15 retries it still failed, then we will have a narrow log.
All right. Yeah, and there's some benefits to having multiple instances handle these, right? Because then you kind of just spread out the load. So yeah, it would be interesting to test in different scenarios and see what works best, especially for the generate and even for the policy report.
Right. I guess the multiple instance can be one solution, and also we now have 10 workers sitting in each generate controller. That's another approach.
Right.
Yeah. Okay, and the next for the policy controller, I haven't thought through the entire process, because in the policy controller, it does two things. One is to like update the generate request based on the policy's activity, and another is to build and create the report change request. This report change request is used to create the policy report. So the policy controller does two things, and I guess for the policy report part, we'll have to change the other two controllers as well if we're making the change in this report policy controller. The other two controllers are the report change request controller and the policy report controller. But I guess for the generate part, based on the policy's activity, it's okay if we update the same generate request multiple times, right? If any generate policy has changed, the final result in the generate request should be the same. So if it's already there, then there's no difference. If it's not there, then updates the same generate request. I don't see there's any problem in it.
Yeah, short term, it's okay. Just in general, we should still
Right.
default to leader election eventually, because there's one unfortunate thing that could happen, which is if I've only experienced this a few times. If like the time is wrong on a node, then if you do like comparisons, you can think like the controller can think that the change is like the other way around, and we get on race conditions and so on. But that is a minor problem that can occur. So for the first iteration, this should be fine. The other thing to be aware of is just that we should at least check once or twice when we do this, or like at least test it, how many API server requests we're creating, because I don't know on top of my head how the controller works right now, but it could lead to like some cascading issues where we change something, different controllers watch this object, and then we basically flood the API server a little bit for a while. But I'm not sure if this will happen here. I don't think so.
Yeah, I agree. We have to test it thoroughly to make sure if we don't change it right now, it won't bring any problem to it.
Yeah, so adding the leader election seemed fairly straightforward, right? So to me, it just seems like we should add that in and then design for somehow splitting and spreading the work, and see what's the best way for different instances to perform work. But maybe for now, just starting with the leader election just seems like the best approach.
So just again, from the operator side, I know that, for example, most of the kube builder operators, they don't split any work. So the leader is doing all the work while the non-leaders are just there for redundancy.
Okay. Yeah, so maybe, and even if we take that approach and just add in the leader election and make the workers, the task workers tunable, even there, of course, we have to make sure that we can handle several concurrent requests, things like that. But there we're sure that they're handling different tasks, right? We're not there's no race conditions on the same resource. Yeah, so maybe that's a reasonable approach to start with, and we just go ahead and add that in.
Yep, agree. Just notice that this policy controller, RCR, report change request controller, and policy report controller are somehow coupled because they're listening on the object that the previous controller is managing or updating. So if we want to make change, we have to just make sure we need to change all of them.
Yeah, this is kind of the scenario I said before. Like this could, if we don't have leader election, this has the potential to create a lot of requests.
Yeah.
Right. Okay. Yeah. So let's just plan for adding leader election in each one of these modules. And I think this, at least for me visually, this gives a good mental sort of picture also, that we have like the webhook requests coming in and one component handling that, and then we have these three major controllers like behind the scenes, like doing the different work. So I think, yes, we're doing this. If there's a even some package level reorganization we need to do to support this mental model, that may be good to look at.
Yep.
So one other thing, you mentioned shooting on the, going with the controller runtime versus client Go, and for historic reasons, we had started with client Go, but I think longer term, there may be some value in still revisiting controller runtime, right? And I don't know exactly the differences. Marcel, I'm not sure if you are familiar with the pros and cons, but seems like there's just higher level abstractions and things we can leverage in controller runtime, which we should probably add to the roadmap at some point.
I'm not exactly sure, because I've been mostly only a user of these packages. So I've never been like I've mostly used it through Cube Builder, and there the abstraction is, it's like all abstracted away, so it's very simple to do there. So I'm not exactly sure what the differences would be. Or
okay. All right. So yeah, for now we'll just seem more straightforward to stick with client Go and what it provides. So we'll do that and then revisit at some point.
sounds good to me.
So
Okay.
just in terms of the work shooting, seems like there's at least like 3 or 4, or I guess probably one task for each. We can create one issue or for each one of these modules, or
yeah, I guess high level we can create those 4 tasks, but going more details, there might be more changes in each control. I can create those for, I think we already have one for webhook. I can create the rest issues.
Okay. Sounds good.
Right. Anything else we want to discuss?
I didn't put it on there, but since this was a discussion that I created yesterday and we seem to have 20 minutes, I want to bring it up. I can put it in the document later. This is about I wrote the issue around the flattened schema paths and where Kyverno mutates those today based on different pod controllers. And I updated the discussion, but I'm not clear, and this is something I want to put in the documentation as, and I mean, I kind of lay it out here, but the ask is to understand where Kyverno is mutating these things today, and why, and where it's not doing them, and what the gaps are, so that we can figure out how to document this, and also how we can improve it. So there are kind of 2 things. There's the items 1 and 2 there. So there's the JSON 6902 patch, and there's James path expressions, and they're 2 separate things. But what is Kyverno mutating today when a user hands it a policy and it has one of those 2 things? So where is mutation of the path being done today?
I think this is only done when we're converting to the autogen rules. That's where we need to change the paths.
Right, that's what I mean. But on what conditions is that being done? Is it only being done for mutate rules, or on which of those 2 types? Like, I want to understand.
Yeah. So I think the only pattern we support for the autogen is the mutate overlay, or you could say mutate strategic merge patch, and the validate pattern.
Okay, but those aren't the flattened schema paths. Those are the unfolded ones, right?
But you could use variable inside it, right? And we recently add the API call, which also you can also define the variables James paths in it. So that's where we need to mutate the path.
Right. So that's what I'm asking. Where when those James path expressions are used as far as variables, because the variable is a James path expression, right? In double braces. So in those cases, and in the JSON 6902 patch, again, the flattened form, not the unfolded form, is there any mutation of those going on today or no?
I don't think we are, right? So I think there wasn't, I recall there were some issues and discussions on adding that, but I don't think we're changing those paths dynamically when we do the autogen.
Okay.
So that could be an enhancement, and that should be, right? Because it would just simplify. And like you have mentioned in this discussion, if we just check for like request object and, do it accordingly, that should be fairly safe to do. Because other variables we can't really change, but for the request object ones, we should be able to.
Wait, in the mutages and patches, we do not support autogen. And for the supported ones, we already changed that. We already mutate the paths.
So I think if we add this feature, then potentially we could support autogen even for the mutate patches, right?
Yes. That's what I was suggesting yesterday. I think we can support it in the JSON patch and validate it, right? I feel that's a lot more easier for user to use those kind of policies.
So, so I think that clarification of what we probably need to document is exactly where AutoGen is supported and where it won't work, right? And today, and what we want to then enhance if we implement what you just mentioned here.
Yeah, I think we already have that, but just in case if we want to extend or explain it in more details, like we have a note here that it only the supported pattern for the AutoGen and what does not support.
Okay.
Yeah, but it's more than that though. It's a case where AutoGen might fire and mutate the rule, but there's an element within that rule that may be a variable, that the variable clearly refers to a schema element, but it's not being updated. And so that invalidates the rule then. So for example, you've got a validate rule and it operates on kind pod. And part of that validate rule uses a variable that's a James path expression, but that variable refers to a specific path in the request. So AutoGen fires, it mutates the rule, it adds the necessary pod controllers, but it just copies the overlay into each one, but it doesn't update the variable itself.
No, I think we discussed in another thread, and Venkatesh already did that job, right? We changed, when we're converting to the AutoGen rules, we changed the path, we mutate it. So it's like when you refer to request.object.spec, we automatically convert it to request.object.spec.template.spec.
Okay, so that's what I was asking. So then, as long as it's an overlay or a validate, then the variables will be mutated, but only in those two conditions.
Right.
Yes.
So it seems like patches, so deny rules, like it says here, generator rules, and then patches, JSON patches are not supported. So I guess maybe, yeah, the only change we should make to the docs is to just explicitly say that the JSON 6902 patch is not supported today, but seems like it can be.
Right.
We just have to add support for that.
Yeah, and anything in the API call schema, right, that's not going to get mutated regardless, right?
No, I think we changed that, all the pattern there. Is that right, Venkatesh?
Yes.
Okay, so when we're converting to the AutoGen rules, we change all of the referenced variables if it's for a pod.
Okay, I'm still a little confused, but I'll figure it out.
Yeah, I guess, right.
Yes, to me, it seems like it's basically this, except we should clarify that JSON 6902 is not supported currently. That seems like the only gap, but everywhere else, if we see variables which refer to the spec, the request object spec, we will change them.
But we're not changing anything that refers to request.object.metadata key, right? That's gonna remain, because Shooting, that's one of the things you said that I wasn't quite clear on, because that shouldn't be mutated.
I think that problem is if you have mixed kinds in the match block. If you're matching to the pod controller and the pod at the same time, we do not want to change it.
Oh, okay.
But if it's only for the pod, we may still need to change that.
Okay. All right. I see.
Yeah, and that's another condition where AutoGen, we added that check too, right? AutoGen will not trigger if you have multiple kinds. It
Right.
only triggers if you've written the rule for a pod.
Yes, exactly.
So we probably need to add that as well, right? Because I don't know that we call that out specifically in autogen rules. So a prerequisite is that the kind has to be only pod.
Right.
Yep.
Right. Okay. So I'm taking notes on this.
Okay, thanks.
Yeah, I'll update the discussion. I think I just need to see I need to see the written down the exact instances where these variables are getting updated. Like I understand the 6902, that's pretty clear. But the other ones, in which case, I'm talking about the variables that are in the double braces, like where exactly, under which conditions are those getting mutated? But I'll update the thing. It just helps seeing it in writing, I think, better.
Right, I can find that PR after the meeting, and we'll know that the exact change.
Okay, yeah. Again, I'm just thinking longer term. These James path expressions and the variables are key in a lot of cases to writing policy that you couldn't write any other way. And there's a little bit of confusion that I see from time to time. And as far as why doesn't this work? This looks like it works. It worked for this. It doesn't work for that. Why? And trying to figure out what the gaps are and either documenting them or putting those as action items to try and enhance. So
right. Yeah, and it's interesting, right, to see how the custom James path functions also seem to be helping out quite a bit with some of these more complex things. But there we'll want to make sure that the CLI can be useful for testing policies, right? Because otherwise it's hard to do with just standard JP and other things, since we've added now custom functions.
Yep, exactly. Okay, that was it.
All right. Any other things we want to discuss?
Just in terms of the release, are we, tracking to putting something else out like this week, or?
Currently, I think Venkatesh is working on one of the PR changes. We require some changes there. And the other one is about the schema validation in the CLI. So
Okay.
we introduced it in 1.3.5, and we found that we have some issue when validating the selectors, the match labels field. So it returns us some invalid message. So we have to figure that out.
All right.
Okay, I guess that's all for today. Thank you, everybody. I'll see you next week.
All right.
Bye.
Thanks.
Bye.